In this section, we are going to discuss about the remedial measures of the multicollinearity. How we can check the how we can solve the problems of the multicollinearity. First one is that do nothing. This theory was mainly, or this school of thought was mainly expressed by Blanchard, and according to him, multicollinearity is essentially a data deficiency problem, and sometimes we have no choice over the data we have available for the empirical evidences. So therefore, do nothing with respect to the multicollinearity. Then second one is the a priori information. Use some other the theoretical and other knowledge for solving the multicollinearity problem with respect to the variables, etc. This is the a priori information. Third one, combined cross-section and time series, that we have already seen that it is a sample problem, and therefore we can combine the cross-section and the time series data, or we can use panel data for solving the problem of multicollinearity. Then another method is that we can drop the variable which are collinear, and the specification bias is also another important problem for multicollinearity. We can therefore use correct model, or we can use correctly specified models for the estimation. Then we can use transformation, that is we can take the first difference or the log or other functional forms to check to control the multicollinearity, or we can add new data problem. Mainly the data deficiency is the major problem. Therefore, we can use additional or new data to solve the problem of multicollinearity. Then we can use the reducing collinearity in the polynomial regressions by using so many methods, and we can increase the number of sample data, etc. Some of the important methods we can use for the solving the problem or as a remedial measures for the multicollinearity. The first one is a priori. Use the a priori information for solving the multicollinearity. Let us see this equation. Here yi equal to beta 1 plus beta 2 x2i plus beta 3 x3 plus ui is the specified model, where y is the consumption, x2 is the income, and x3 is the wealth. Usually this income and wealth are more or less same. In this, we can, instead of using these two variables, we can use some other variables which are good proxy for this model, and thereby we can solve the thereby we can solve the problem of the multicollinearity. Second one, we can combine the cross-section time series data, that is we can use the panel data, or by pooling the data we can solve the problem of the cross-section. Then next one is dropping the variable and specification bias, that is if we find that one variable is collinear, drop that variable, then we can solve the problem of the variable. Then transformation of variable, that we have already seen. The first difference ratio transformation, etc., can be used for solving the multicollinearity problem. Then additional or new variables, that is since multicollinearity is a sample feature, it is possible that in another sample involving the same variable, collinearity may not be so serious as in the first sample. Sometimes simply increasing the size of sample may attenuate the problem of multicollinearity or collinearity problem. As the sample size increases, sigma x23 will generally increase. Therefore, for any given x23, the variance of beta 2 will decrease, and thus decreasing the standard error, which will enable us to estimate beta 2 more precisely. Thus, as the sample size increases, this will increase, and we will get the smaller variance, or the variance of beta 2 cap will decrease, and it will decrease the standard error, and which will enable us to estimate the beta 2 cap precisely. This is the additional data. The next one is multivariate statistical analysis, like factor analysis, principal component analysis, regression, etc., can be used to solve the problem of multicollinearity. Then next one is the reducing collinearity in polynomial regression, and a special feature of this model is that the explanatory variable appear with various powers. Thus, in the total cubic cost function involving regression or total cost on output, there is output square, output cube, which we have already discussed. The various output terms are going to be correlated, making it difficult to estimate the various slope coefficient precisely. That is, in the case of the in the case here, reducing collinearity in polynomial regression means In the case of the polynomial regression, there will be every chances of the high collinearity. We can take in deviation forms or other techniques like orthogonal polynomials, etc., to solve the problems. This about the remedial measures.